To evaluate the risk, we have to take many factors into consideration. How, where, how much and how long one can be exposed to the hazard are all things to be taken into account. Toxicological research can map the potentially harmful properties of a product, be it chemical, physical or biological, and it can also set a limit under which exposure will have no effect. Based on this research, a risk can be calculated based on frequency, conditions, and length of exposure. However, some types of risks are hard to quantify, either because of the complexity of a system, like in the case of climate change, or because we still lack some of the tools to measure it, like in the case of nanomaterials. When there is no consensus on the level of risk, policymakers sometimes apply the precautionary principle. When sufficiently established elements suggest that an activity is seriously expected to potentially produce irreversible damage to health or the environment, measures should be taken even if the definite proof or the causal link is not yet formally established with absolute certainty. It is best to err on the side of caution. Nevertheless, the precautionary decisions should remain proportional to the potential but uncertain risk and be re-evaluated when new data become available. Indeed, the proportionality principle is and should be at the base of most legal thinking. Now, how can we manage a risk? Risk can thus be managed by limiting exposure to a danger and by the adoption of risk reduction measures. Prevention might be a better idea to reduce risk. For example, driving has been made safer by speed limits, the use of seatbelts, bumpers, airbags, driver assistance systems, etc. But what is considered safe? Acceptable safety levels greatly depend on where you are on the planet, culture, socio-economic criteria, and the sector. Similarly, the safety limit adopted for a pesticide like DDT has to be balanced with its importance in safeguarding health or food resources in some regions of the world. For each specific case, an acceptable safety level has to be determined. This is thus not only a technical but also a political decision. Even if the previous steps are logical, what is considered safe has to take into account the perception and acceptance of risk. These tend to be emotional and rational at the same time. For example, flying is commonly considered a greater risk than driving, although all statistics point to the contrary. Moreover, once a perception of risk sets in, it is very hard to change, even if all evidence points to the opposite. In a nutshell, risk and perception of risk are not always aligned. This can make political decisions difficult to make. In these cases, it is especially important to base them on facts rather than on opinions.
Studies have consistently shown that the average person believes he or she will live a longer and healthier life than the average person. We overestimate the likelihood that bad things will happen to other people and underestimate the likelihood that they will happen to us. It's a natural part of our psychology, but yeah, we miscalculate risk in many fascinating ways. Casey Cole points out that we are often more responsive to threats that are personal, exotic, erratic, and dramatic than we are to threats that are, well, more likely. Imagine a world where cigarettes are harmless, but one cigarette pack out of every 18,750 contains a single cigarette laced with dynamite that, when lit, violently explodes, blowing the user's head off. People would be loudly and messily losing their heads every day all over the world. But in that imaginary universe, the same number of people would die every day because of smoking that already do. The results would just be more shocking, more immediate, and probably more likely to affect our decisions. Our myelinated machines use more biases and shortcuts to evaluate probabilities than can fit in a single video, but a particularly strong example is the availability heuristic, our tendency to think that something is more likely because it happened recently, or there are more examples of it happening available in our memories, not because it actually is more likely. We also over-exaggerate risks we don't have control over, while being comparatively fearless in the face of equal risks we nonetheless can control. Chauncey Starr's famous 1969 study on risk found that people were willing to accept risks 1,000 times greater if they could control them, for instance, driving a car, than if they didn't have control, for instance, a nuclear disaster. Let's talk about Abraham Wald. Only so much extra armor can be added to an airplane before it becomes too heavy to fly. Now, during World War II, the US military noticed that planes returning from enemy territory were usually damaged around the wings, the body, and the tail gunners, so they put more armor on those areas. But it didn't make a difference. The same number of planes continued to be lost. So the military hired Wald for his mathematical superpowers. He told them to put what little armor they could on the parts of the planes that weren't being hit. Why? Well, because returning planes were survivors. They took damage in areas where a plane can take damage and survive. Damage to other areas caused the plane to not return. Wald was protecting them against survivorship bias, only paying attention to successes. Wald's work saved thousands of lives and made flying safer for many more. A few risk scoring systems have been created to make the discussion and comparison of hazardous behaviors clearer. The Micromort was conceived by Ronald A. Howard and is an amount of risk equal to a 1 in 1 million probability of dying. A single skydive temporarily increases your death risk by 7 micromorts, a 7 in 1 million chance of dying. That's the same as smoking 5 cigarettes. It's been estimated that you gain 1 micromort for every half liter of wine you drink, every year you spend drinking Miami tap water, every 1,000 miles you fly in a jet plane, every 230 miles you travel by car, every 20 miles you travel by bicycle, and every 6 miles you travel by motorcycle or canoe. There is a happier unit of risk, the microlife. Proposed by David Spiegelhalter and Alejandro Liva, a microlife is gained by doing healthful things. In small quantities, their benefits are roughly linear, and 1 microlife is the equivalent of 30 extra minutes of life. 20 minutes of moderate exercise gives you 2 more microlives. 2 hours of sedentary behavior, -1 microlives.
Our world is at risk. Accelerating change is making our world more vulnerable to global shocks. Shocks that don't respect national borders. Shocks that have the potential to shake whole systems and societies to their foundations. These risks are divided into 5 categories: economic, environmental, geopolitical, societal, and technological. By understanding their seriousness, likelihood, and potential impact, institutions develop strategies to defeat them and to mitigate against their harshest effects, as well as to help build communities and businesses that are resilient and adaptable. Together, we can shape our global future, project short-term vision and vested interest, and work together to find creative and innovative ways of protecting our people and our planet.